Hey everybody, it's Mr. Phil here, and I'm really excited to bring you this new tutorial. It's my first one for the 2017-18 season, Relic, and it's all about the new programming method that you've got available for you this year called OnBotJava. And just as the name said, it's Java, but it's on the robot instead of on your computer. So it lets you develop faster with all the capabilities you have with regular Java with Android Studio. So there's 5 sections that are somewhat disjointed, so I'm just going to let you know what's coming, and if there isn't a clean segue between them, it won't upset you. First off, I'm going to just discuss the new OnBotJava in relation to the existing 3 programming styles. And then I'm going to show you how to set up your phones and get the information you need from the app so that you can use the new OnBotJava. Then I'll show you how to connect your browser to the phone, and you can do this with a Chromebook or a tablet or anything you're comfortable using. It doesn't have to be a fancy computer, no need to load software. I'll show you how to create your first OpMode using one of the built-in samples, and then I'll show you how that runs, and then I'll show you a way to use one of the more sophisticated samples. All of the samples that existed in the Java Software Developers Kit, there's probably about 25-30 of them, they're all echoed, mirrored if you like, in the OnBotJava environment. So anything that you could do with the old setup, you can do with the new setup. The syntax is the same, the programming methods are the same, other than the fact that it's faster and easier to do just because you're not plugging and unplugging and stuff like that. So even if you're an Android Studio person, you may want to look at this, because if you're helping out other teams or if you get a new team started, it's a great way to get them on the road with full-blown Java if you think they're ready to go beyond the block-style programming. Anyway, no further ado, let's move on and let's do the overview. So, when FTC first started using the Android phone to control the robots, there's my phone, here's my robot. There was initially only 2 ways that you could develop code for the robot. Both of these ways needed a full-size computer. The first way was Android Studio, and it was a Java text-based programming language. You needed to load a bunch of software onto the computer, and once that was done, it would download the code to the phone as an app using a cable. The other way that you could code, if you didn't want to use the written Java interface, is you could use MIT's App Inventor. And it was a Scratch-style block programming language. You still needed to load a bunch of software on the machine, the App Inventor and the server that did the compiling and downloading, which it did also as an app onto the phone through a cable. The next year, a new feature was added. It was called blocks, and this mirrored the App Inventor style of block programming, but instead of running all the software on the computer, it actually only required a web browser. So you could use a tablet, or you could use a small Chromebook, and it would download the code to the phone wirelessly. This was really cool because this was easier for schools to use because they didn't have to load up a lot of software on their machines, but it did assume that you were going to use the block style programming. This year, to complete the suite, a new style has been added called OnBotJava, or OBJ, and it is a full-blown Java programming style. In fact, it uses exactly the same code and modules and style as the Android Studio development, but once again, it's only very thin requirement. It only needs a browser because it's actually communicating with a web server on the phone wirelessly. And so you write your code on the tablet, and then it gets downloaded to the phone as OpModes. So both of these solutions down the bottom here have the advantage that they don't require custom software to be loaded on the laptop or on the Chromebook. So it's great for schools. It's also very quick. Once you have written your code here, you hit a button and it builds and deploys straight to the phone, at which point you can run it, so there's no need to do app downloads and compile. Because this is supported by a browser, it's not as capable a development environment as the Android Studio. But for new teams, developing teams, teams learning Java, it's a great environment. All of the samples and examples that exist on Android Studio also exist on the OnBotJava, so you can load them onto the phone and develop them, modify them, customize them to your heart's content. So these are the two thin client-based, and these are the two heavy PC-based applications. All four of them are great solutions. Now that we've seen the four different programming methods, we're going to take a closer look at the OnBotJava, the new Java programming method, and we're going to look and see what's required just to get it up and running, connect, and do some basic programming. I have two phones that have been configured using my standard configuration method. It's on my tutorial. It shows how to get the phone set up, how to give them their names, what features to turn on, what features to turn off. In addition to that, each of them has had their appropriate app downloaded from the Google Play Store. So the phone on the left has its name 2818 CRC for robot controller, and it has the standard robot controller app installed. The other phone is a 2818 CDS for driver station, and it has the driver station app installed from the Google Play Store. So now we can just start from here. So the first thing we're going to do is just start up the driver station. And it should say network not paired. If it says not connected, it's probably because the app was already running, and then the easiest thing to do is just to swipe the app off and start it up again, because we want it to say not paired. Now I'm going to actually start up the robot controller app, and instead of just starting it, I'm going to verify the hardware's and the cabling is correct by taking the phone, plugging in the cable that connects it to the expansion hub, because that's what I'm using, and because I plugged it in, it's powered up the expansion hub and has launched the app. If it gives you a prompt about is it okay to associate this hardware with this app, click the always button and accept it. So now at this point they're not communicating and there's no configuration set up. So if I go to settings on the driver station phone, pair with the robot controller, it should offer me this phone. If you've named these phones correctly, the name will show up here. If the phones are just randomly named, because of the filter being turned on, it won't show you your phone. If your phone doesn't show up here, you can try turning off the filter just in case you've named them incorrectly, but it should show up here. I'm going to select it, and then I'm going to back out of the screen. And quite often what I like to do is, if it doesn't connect straight away, just exit out of the app and comes back in again. But you see now it says network 2018 CRC, and it's got a low ping time, so we know it's up and running. So just for fun, I want to show one of the other cool options, obviously from this year. Settings. You can change your color scheme. Robot color scheme, driver station color scheme. I kind of like the purple. Other than just the purely cosmetics of this, it does make it easier to identify perhaps one set of phones from another set of phones. If you have several sets of phones, you can instantly tell which phone's which based on the color. So I'm just going to take these back just because it's easier to see on the camera. Oopsie, wrong screen. Color, red, red. So now I'm going to go in and configure the robot hardware. This is so that the sample programs, or any of the programs you write, can talk to the devices on your robot. And in this case, we only have two things. We have the left drive and the right drive. So we're going to configure those. So if I go into the menu, configure robot, it says there are no configurations found, and I can select a new one. Now I can go in and select new, it'll find the hardware, and then I'll have to put in the names of all the drives. But if you're just getting started and you want to experiment, the easiest way to do this is to configure it from a template, because we've set up a RevScoot template here that knows the names of the left and right drive. It assumes the left drive is in the motor 0 and the right drive is motor 1, just like I show in the little video introducing the Scoot robot. So if I just say configure here, it has now found the hub and it's set up that configuration. If I have a look in here, I can see that the motors are all set up with the left and right names, so everything's done there. So the last thing you need to do is you need to save this, and I'm going to call this Scoot. Okay. Then I'll back out of here. It's selected, and now it should go and communicate with the hardware. Alright, initializing, so everything's up and running now. And when that connected, the light on the expansion hub changed to a green and blue flashing combination. It stays green for a long time, and then it flashes blue, and the number of blue flashes is the module number. The modules come configured when you buy them as code 2, and if you had multiple modules, you'd configure the other ones as 3 and 4. But anyway, so we're up and running here. So at this point we've chosen a configuration, we're connected to the hardware, everything's fine, the driver station and robot controller are talking to each other. So at this point you're ready to start driving, start doing something. Now, because we're using the OnBotJava, we have some really easy options here, but first thing we need to do is get it so that your laptop or whatever can communicate directly through to the robot controller phone. So for this, there's a special mode here. And normally when you start up the robot controller, it automatically goes into the mode whereby you can connect to it. But because you haven't done this before, you really need to go in and let it tell you what to do. So I did okay, do that again here. Program and manage. And what it's going to do is going to tell you how to connect here. So if you read through this, it'll tell you that the network name for this device now is Direct D3 2818 CRC. So you'll see the last part of that name is matching the robot controller name. So in theory, if you open up your network connections on your laptop, and we'll do that in a second, you'll see this device, and so you connect to it. When you do that, it's going to ask you for a passphrase, and that's displayed underneath here. In this case, it's 88QH and a bunch of other characters. The upper and lowercase is important. So once you enter that passcode, then your laptop will connect to this phone, and it'll be ready to program. The last thing you need to do is take your browser and point it to this address on the phone. So once you're connected, you can open up a browser window and type in http:// and in this case it's 192.168.49.1:8080. This is always the same. So once you've done this once, and you've set up and you've gone to this address once, then you can either bookmark it or your browser will probably remember it, and then every other time you go into program, all you need to do is bring up a browser, start typing in 192, and it'll bring you back to this address. And it tells me that the server's okay, and that the robot controller is connected to the same server. So we're going to now drop into the programming portion. So I'm going to switch over to looking at the laptop screen, but just remember this, when I reference these numbers, they're coming from this screen. And you can back out of here at any time, and anytime the robot controller app is running, or even in the background, this window is this browser interface is available for you to do programming. So here we are at the web browser, and we have currently got our robot controller phone on, and we have the program and manage screen up, which shows us our connection information we talked about a few seconds ago. So the first thing I need to do is I need to go down and connect to it. Now if you have a look at my selections here, there's two general access points, and then there's two Wi-Fi direct. One of these is my printer, and this one, if you recognize the name, is from the name that we saw on the robot screen, and it includes the robot phone name at the end, 2118 CRC. So I'm going to select that, and I'm going to connect, and it asks me for my network security key. So this is what was displayed on the phone when we brought up that pane, and it seems to be different now. 34TX QYFJ. So you would enter whatever shows up on your screen. I think this security password may change, perhaps on the new loading of the program, or perhaps each time the phone is powered up. I've only come across a couple of them here, so not quite sure how often it changes. So it's going ahead and it's connecting. it should connect, and it'll say that there's no Wi-Fi. Sorry, it'll say there's no internet because, of course, the phone's not connected to the internet. So while it's doing that, I'm going to now do the third thing in the process, which is to go to the website. So if I go HTTP, and you see because I've been here before, it automatically shows up. So I'm just going to hit return, and it's now brought me to a web page which is actually coming from the phone, and you'll see that it's mimicking this first page here, mimics what was showing on the screen on the phone. It's just duplicating the information, showing the connection, the passphrase, and now it's showing two active connections. The robot controller is one and Windows is the other. So you can experiment with these pages. This first link is for blocks programming, but we're not doing that right now. We are doing OnBotJava, and here's the OnBotJava menu. Now you can see here that we have on the left we have a project tree, and it shows us any files that we have that we're working on, any opmodes or any classes. Then on the top right we have the code editing screen, and it's got a little tip here to how to get started, and on the bottom here we see our build status, our build output. So the easiest way to get started is just simply start with adding a file. So we're going to go up here to add file. It's going to pull down this little list here, and we can give our file a name, and this is actually going to be the class name. So if we just put something generic in here and try and do this, it's going to say it's not valid. We need to use uppercase camel format, which is has to start with an uppercase letter, and each of the words in between are uppercase letters. So I'm just going to call this my OpMode, and really the key thing is the first letter has to be uppercase, so because it matches a class style. Then we could just add that and say let's do it, or we could actually grab a sample. Samples are the easiest way to go. So if you want to drive, you want a basic OpMode, and you want it to be fairly straightforward, then the linear OpMode, basic OpMode linear, is the easiest way to go. I'm going to select that, and we're going to say Teleop. And if we say autonomous, it'll show up on the autonomous pull-down list. If we say not an OpMode, it won't show up on either list. And if we say preserve sample, it'll do whatever the sample's got in it. And in this case, the sample is disabled, so we don't want to have a disabled OpMode. We want to have a real Teleop OpMode. So I'm going to say OK. It's going to bring it up here. So now I have my Java file underneath my team code folder, and the code is over here on the right. The first part of the code here is the header, and then we have a bunch of includes, or imports, sorry. Package name matches the folder name. There's some comments in here that are worth reading to explain what's going on here. One key thing we can do is we can change the name here that appears on the driver station pull down list. So this could be run me, and so that's what will show up on the pull down list. And this code is fairly straightforward. It declares some variables. The run OpMode method is what gets executed when you hit a NIT on the phone. It goes in, it displays initialized on the screen, sets up the drive motors based on the names left drive and right drive, and they are what was set up in that template that we created earlier, so they will match. So we'll get a nice name match there. It sets the right hand drive into reverse because seeing the motors are pointing in opposite directions, one of them has to run backwards in order for the robot to drive forward. Then it does a wait for start, which is waiting for the driver to hit the start button, and then it goes into this loop here, and in the loop it calculates the drive power for each motor and outputs the power here. In between there's two choices you can use. You can either use the POV drive mode, point of view, where it's a two-stick drive where the left stick is forward and backwards and the right stick is left and right. That matches most game playing modes these days, and it enables you to drive slowly forward quite easily. The other option is tank mode, which is down below, that if you comment out these two lines you'll get tank mode, and that's where you just each stick corresponds to one wheel, and it's up to you to balance the power to make it drive straight. It's a little trickier to drive that way. Most people, once they see POV mode, they go, oh yeah, that's what I want, and then it displays some data. So if we want to, this code here is currently on the phone now, but it's not built into an OpMode. To do that, we need to run the build everything button over here, and down below here we'll get a status. So 1.6 seconds later, it has now built that op mode and it's ready to run. So if we go back to the phones now, we'll now see that this is an option that we can run. So here we are back at the phones, and you can see we still have our program and manage screen up, and it's actually showing two connections now, the robot controller and the Windows. So I'm going to exit out of here. Once we've used this to set us up once, you really don't need that screen ever up again, because whenever the robot controller is running, it's available for coding. So we haven't done any new downloading or anything, haven't plugged in the cables, but if I go over here, I can see the Run Me Teleop mode, which is what we called the one on the OnBotJava. Hit the Run Me, initialize, and then I can run. And now if I had a joystick connected to here, I could drive the robot. So that's cool. So I'm going to stop that, and without touching anything on the phones now, I'm just going to go back to the laptop and add a couple more opcodes. Well, one more opmode. Okay, so we're back at the programming screen, and I'm going to add another op mode, but in this case I'm not going to use the simple op mode. I'm going to use one of the slightly more sophisticated op modes based on the PushBot series that were created for last year's Android Studio project samples. So I'm going to go into add here. I'm going to call it, this is going to be an autonomous one, so I'm going to call this my auto. I'm going to go down autonomous. I'm going to select it. What I'm going to do is I'm going to select a pushbot drive by time. So this is a simple autonomous example that shows how you can use time and motor control speed just to drive the robot in a simple path on the field. If there's in a lot of cases you can always get some points just by doing a little bit of straight driving, a few turns maybe, push something out of the way. So if that's the case, there's no reason why not to try this drive by time example and just change the times and distances to match what you need. So I'm going to select that, autonomous, and okay. So now I have a my auto and my op mode. I guess I should call this my Teleop. So I'm going to change that. I'm going to right click on it, rename my Teleop. And one thing to notice is that when I change that name, it actually changed the name in the file here. So it's smart enough to know that if I change the class name here, it has to change it inside. Anyway, I go back to my auto. So this something special about these op modes is that instead of having all the motor and servo code in the main op mode, they do it based on using a class. In this case, the class is called hardware pushbot. Now this class is actually in another file, but you may not necessarily know that, but when you go to build it, it'll tell you quick enough. So you'll see that when I went to build that, I got two errors here, and if I have a look, it says line 63, column 5, error, cannot find symbol, and the symbol is class hardware pushbot. So if I have a look here, line 63, and it says this is where it's trying to get the hardware pushbot. So as with the other samples, there are actually two files required, the opmode file and the class file. So where is that? Well, it's where all the other ones are. If I go down into my sample list, we'll see that there is actually a hardware pushbot class here. Now this is not an opmode, so that's correct. And in this case, because we need the class to be named correctly, we need to make the file name exactly the same as the class name. So in this case, it's hardware pushbot. So now I have my three files. I have my Teleop that just did its own thing, and then I also have my autonomous that uses the hardware class. The reason we use this method is you may have multiple autonomous programs, but instead of putting all the motor and servo setup code in them, you just put it in this one class, and all of the autonomouses can reference this one class. So if I build it now, alright, so this is a glitch that I'm not quite sure why it's coming up, but every now and then you'll see a build fail and it says 0.1 seconds. That's not enough time to have failed. and if I run it again, it will come up and it'll give me a correct build. So if you ever see that build fail with a really short time, just click the build again, and chances are it'll build properly. So at this point, these two op modes are now in the phone, fully ready to run with no additional downloading. So I'm just going to switch back to the phone now. So once again, here we are back at the phone. It's exactly where we left them before. You can see that it just recently would run the run me, but now because we've done a build on the OnBotJava, the run me is still there, but over here on Autonomous, now there's the pushbot auto drive by time. We didn't rename that one. We didn't rename the menu option for that one, so that was the original one that came through from the sample. So in theory, I can initialize him, and if I said run, it madly thinks it's driving around on the first leg, the second leg, the third leg, and then it's finished its little path. So you can see how easy it is here to create and build and deploy new op modes wirelessly, and then run them very quickly without having to plug in cables and deploy and all that other stuff. So it's pretty cool.
Hi, this is the Scoot robot that I'm going to be using to show how easy it is to use the new FTC SDK to get your robot up and running. And it's built completely with the Rev Robotics hardware kit. It uses their standard equipment, all plastic fittings, the aluminum bars as the cross supports. It uses one of the new Rev expansion hubs to control the robot. This will let you do 4 motors, 5 servos, and a bunch of other bits and pieces. It's using a ZTE phone and 2 motor drives, 2 of the new Core Hex motors. It's a really basic drive system. It uses 2 traction wheels on the back, and these are just chain driven for a little bit of increase in speed, one on either side. It has 2 Omni wheels up front. Eventually probably put a chain from the rear wheels to the front wheels on those, but right now it really isn't necessary to show how the robot drives. It's got one of the new flat battery packs on it. I'm going to plug that in. You'll see the power light come over here. Right now the phone is off, otherwise it would have already been powering the expansion hub. The wiring is pretty straightforward here. It uses 2 of the motor outputs, 0 and 1. 0 is wired across to the left motor with both a power wire and an encoder cable. These come with encoders built in, so you might as well just assume you're going to plug them in. They're always more useful that way. And on the right side, the right motor comes down here to expansion, the motor port 1. So we're using 0 and 1 for the left and right. This matches the configuration template that's in the phone. So if you wire them up that way, left 0, right 1, everything will come up automatically and you won't have to do any of your own configuration. There's a single cable, USB cable. It's actually 2 cables that are joined together, but going from the USB mini to the USB micro, and that allows the phone to communicate with the expansion hub. All right,